All right, so I've been asked about question 7 on the packet, and of course, I won't do that exact problem. But in the course of reviewing for the pre-calc semester 1 final, it is reasonable to cover the topic of how many solutions you get to a quadratic. This one, for instance, the first thing I say on quadratics is if you can factor it, you should. Couldn't this one factor? I don't think so. No, you're thinking 4 and 1, but that would have to have a negative in it. And that's not going to make a 3. So bottom line, you can't factor this one. How do you solve a quadratic equation? Now, if the quadratic equation comes out to having a negative under the square root, how many solutions will it have? 0. What if the thing under the square root is positive? How many solutions will you have? Are you realizing what that means about the question you just asked me? Because it talks about having exactly 2 solutions. When would you have 2 solutions? No, this isn't the denominator. What is this thing called? Certainly not denominator. Discriminant. And the discriminant, and it's not when it's negative. No, that then you wouldn't have any answers. When the discriminant is what? Positive. You'd have what? 2 solutions. Okay. What if the discriminant here is less than 0, no solutions, greater than 0, you'd have 2 solutions. What if it's equal to 0? Then you have 1 solution, and it's equal to all this. Think about it. If this is 0, then x is equal to the rest of the equation, which this is the least remembered equation of them all. Honestly, everybody knows the quadratic formula. They forced you to memorize it with singing, and that works, and so everybody knows it. But if I ask, what's the vertex formula? Very few people can pull this one up out of their memory banks. Negative b over 2a is the vertex formula. Why would it be the vertex? Because if it's got exactly 1 solution, think about what it looks like. Do you get it's like this if it has exactly 1 solution? And that means it'll be the vertex of the parabola. Or it could be upside down, but still, if it's got exactly 1 solution, it touches just like that, which means it's got to be a vertex. So this is the vertex formula because the discriminant's 0, that becomes the vertex formula. All right, so I've already answered enough so that you could use that information with your equation and make an answer. The answer comes out to be like, I'm not saying the answer is, the answer will be like a range. Like as long as k is between 6 and 12, know what I mean? All right. So are there any other topics that you want to ask about from the packet? Because I do want to throw in a couple that aren't necessarily in the packet. Maybe they are, and I just didn't notice. But I know we studied them. What I'm not going to do for you is odd and even functions, because I did it on the other video, and I want to encourage you to go watch that video. Okay? So just so you know, there's a formula to see if this 2x squared plus 3x is odd or even or neither. And it is that thing where you go, oh, y is f of x. And if you do f of negative x, and you put in negative x, do you remember the deal where if f of negative x is equal to negative f of x? You remember that? That's the odd rule. If you've forgotten that, you may want to go watch that other video. All right, here's another one where I'll take more questions from the packet, but I want to intersperse here with some stuff that's not necessarily in the packet, but you do need to know for the final. Okay? You ready? All right, here's one. Imagine for a moment that I have this as my f of x. Now, I know right now you're trying to focus on your take-home, but you know what? You're going to get your take-home done. You'll be ready by tomorrow. You have it the last class, so you're going to be the best. You have the most time of anybody to get it done. What I would do is take notes on what I'm showing you right now, because unless you have an awesome memory, 5 days from now, you will have forgotten at least 90% of what I'm about to say. You'll be like, oh yeah, that absolute value thing. I don't remember which one's which. If I were you, I'd take some notes, but it is your life. Okay. Do you remember how to do f of the absolute value of x versus f of x with absolute values around the outside? I'd like you to try that right now. This is not optional. You don't have to take notes. Can't make you. But I can make you do a practice problem. All right. Get out either blank Notability doc or some scratch paper. I have scratch paper on my desk right there. No excuse. One or the other. And write down that question and give it a try. Okay. All right. So now I'm going to remind you how to do this. So this is the part where it'd be smart to take notes. If I do the kind on the inside, wherever the x was negative, and think about that. I'd like you to just shade in the part where x is negative. Do you agree that that's the part where x was negative? Okay. That part needs to change. Do you remember how this went again? Yes? Yeah. This whole thing gets wiped out, and then it reflects back this way. Raise your hand if you already had that. Okay. All right. Then we're going to do absolute value around the outside. Okay, so if I absolute value the outside, that's the y's. I'm going to go back to what it was originally. There we go. Where is y negative? Just this little tail end right here is the spot where y is negative. So that's the only part that has to change. And it's really simple on this kind. It just flips upwards. So final answer is that part is up instead of down, and then it copies back over that. So there's your answer for that kind, where the y's are absolute valued. Okay, so there's just a topic, for example, that you're going to need to know because we studied it. There's other things. You could ask me for more from the packet, but I'm going to do one more thing before I forget about it, and that is about continuous functions. Continuous functions. If I can draw all the way to the end of the function without lifting my pencil, that was a continuous function. Next, it has to pass the rule of, like, for functions, like what is a function? It has to pass the vertical line test. So is that continuous? No, because it's not a function. I never lifted my pencil, true, but it also has to be a function. And this doesn't pass the vertical line test, so it's not a function. All right, so it has to do those two things. How about this one? Keeps going, stops, continues from here, and goes on. That is not a continuous function because I couldn't draw it without lifting my pencil. All right, so the definition of continuous, something that we didn't talk about very much, but now all of a sudden you need to know it. There you go. It's, can you draw it without lifting your pencil? So how about something that has a hole in it? Remember these? And then all of a sudden it, doesn't work right here, and then it just keeps going. Technically, that is not continuous because really a hole doesn't have any outline around the outside of it. You know what I mean? The hole here is really, it's just a gap in the function, like that. And we just make a circle around it to kind of draw your attention to it. So this one is not continuous. All right, enough about continuous. All right, did you notice that that was in your packet? It was. Okay. Next, I want to, one kid asked about these kind of functions where it goes like, it's a parabola until it hits here, and then all of a sudden it stops being a parabola, and it's an absolute value for a little while. And then it starts being a square root graph after that. I called them, just a nickname, Franken functions. They were technically called a piecewise function. Does that ring a bell? All right. So, what do you need to know about these guys? Well, the main tip here is that this one is wrong, for example, because of something. You got to look at the borders. I've been saying this for years, by the way, as just an example. All the trouble is usually at the border. Right now, I'm going to talk about the border of Kashmir. Okay, because that's over between India and Pakistan. They both claim that area. They both say it's ours. So there can be a war over that kind of thing. And what's especially scary about that one is both India and Pakistan have nukes. So if they get especially angry with each other, because neither one's going to let go. Maybe someday, like, one will, like, say, okay, fine, we'll let you buy it from us, or, you know what I mean? Maybe they'll figure out an end to it someday. But India and Kashmir, or the Indian people feel like they own Kashmir. They don't want to give it away to anybody. So again, like in the past, you know, Russia used to own Alaska, and then they sold it to us. I think they would have sold it to us if they'd have known there was a ton and like billions of gallons of oil underneath it. They had no idea that was there. So it turned out to be a really bad idea. Really great for us because we didn't want to have a foreign government that doesn't like us very much on the same exact continent as us. So, anyway, so there's a problem at the border here. Look at, do you get that right there? If I do the vertical line test, it doesn't pass the vertical line test. So you got to be clear about who owns the endpoints. So if you've graphed the middle one and you put like a solid dot here, then this one would need to not intrude over into the other guy's space. And at the very tip where it ends, you got to put an empty spot. So that at that spot, you can tell who owns, like, let's say that's x equals -1. You can see who owns that spot. All right, another thing. When you're making these graphs, you can get confused pretty easy, but remember the XY chart is your best friend in graphing. And so if you're trying to make the graph, make an XY chart. And so these functions usually look like this. F of x is equal to, and it's got a thing like this. And it's like, it's a parabola, x. Let's say this one's a parabola shifted to the left and down. It's a parabola, but, and then it'll say when it's a parabola. Let me move this over. From -infinity until it hits -1. And this guy did not own the endpoint, so we put a parenthesis. The next function would be an absolute value function, except it's moved a little bit to the right, so I'm going to squeeze in a little -1. And it's that from 1 to, let's say that's, sorry, that's -1. -1 to, let's say that's 5. And it owns -1, see, because of the dot there. Bracket. I know I'm not doing the one on your paper. You have to do that one yourself. Just trying to give you an example of how these work. And last, for this from 5 on, that would be from 5 to infinity. It's going to be the blue one. And it looks like the blue one owns it. So that gets bracket. Should do a filled in dot right here. And that looks like it's a parabola. No, a square root. Except it's been shifted to the right. So let's say it's x and then -5. And then it's also been shifted up a bunch. +8 maybe. There's an example of both graphing and making an equation for one of these piecewise functions. It's something you need to know for your test. I've seen it on the ACT test before, and it's something that's on your pack. That goes on my desk. That way you won't use it for the rest of the hour at least. Okay. Yes? Yep. If they were to meet in the same spot, let me show you. Let's say this was down here. That's legal as long as one of them has a solid dot and one of them has an empty dot. Yes? Good question. That dotted line there is not an asymptote. That in my picture, that dotted line is an asymptote. Is not an asymptote. You should not be able to put a solid line on an asymptote, but remember the asymptote goes with only one of your two functions. You know what I'm saying? Let's say this really was an asymptote. Let's say that this was like the butterfly graph or something. Okay? If it was the butterfly graph, it would have an asymptote. And that would apply to it, and it might have an asymptote going this way too. And so it might look like this. But the next function doesn't have to obey that asymptote line. Does that answer your question about the asymptote? Okay. That asymptote would only apply to the butterfly function. As soon as it switches gears to this next little zone here, that isn't an asymptote anymore because that's an absolute value function. It doesn't have asymptotes. Okay, so there's a little something about that. I'm willing to answer more. There's a lot of topics we covered since since September. Think of anything else? Yes. Good question. If you are faced with an answer like, for instance, ln3, on the test it'll say whether it wants exact or not. If it doesn't say, then let's say you think the answer is ln3. Is ln3 something you could get with a decimal? Well, kind of. You can use a calculator to do that. So then the question really becomes, which one's more exact, ln3 or the decimal? Think about it before you answer. Which one's more exact, saying ln3 or giving the decimal? A lot of people's gut feeling is wrong on this one. ln3 is more exact, yes. Okay, so if you're trying to decide, go with the more exact answer. Okay. Now, if they say something in the question like round to the 10th place, that's a big hint they want a decimal, right? Yes. If it didn't say, I'm not going to be mean about it. But if it didn't say, what do you think is better? Exact is generally better than rounding to some decimal place that you're not sure is where you want it to round to. Know what I mean? I'm not saying you should hurriedly go back and find any problems that you weren't sure if it's just, if it isn't clear, you can give a decimal or you can give an exact answer. But generally, how can a teacher argue, no, your answer was too exact? Unless you're talking about sig figs. That's a whole different thing. In science, they can say, yes, your answer was too exact, actually. Okay. Next topic. Anything else you want to know? Sir. I've been asked about problem 3D. If I were you, I'd go look at it in case it's something you weren't sure of. All right. That is bringing up the topic of not inverses. This is important that you get the difference. That's not an inverse. Inverses are where x and y get switched and stuff. This is not that. This is called, do you know? It starts with an R. Reciprocal. This is called a reciprocal of a graph. All right, to do a reciprocal of a graph, this is a classic one that a lot of kids have trouble with, so pay attention. I'm not going to do the one on your packet. You have to do that yourself. But let's say you had something like this. It wouldn't be much different. It was pointy. Still act the same way. Just so you know, the simplest thing is you could take every single point that makes this up. This point, 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 and this point. And you could make a new point for them. What would you do? You would take the x and leave it alone, and you'd take the y and put 1 over the y. So let's take this point right here. Does it? Would you agree that that might be the point like 3, 1? Okay. Then what would the new point be? Hint, leave x alone. It would still be 3, 1. Because when you take the y and you put 1 over 1, you still get 1. So that point stays the same. All right, let's take another point. Would you agree that this point here might be like 2, 4? Give me a new point for that one. 2 comma 1/4. So I'd go over 2 and up 1/4, which is much lower than it used to be. What would be some critical spots when the black function there hits what? 0. When it hits 0, when you have 1 over 0, you have a problem. So the new function would have to have an asymptote like this, wherever it hits 0. So generally speaking, I suggest you find the spots where it hits 0, make asymptotes. Find the spots where it hits 1, because it'll go through those spots again. And then it's kind of like making parabolas. Over here, this is the spot it hit at 1. When this gets really small, 1 over it gets really big, like down here. So this goes this way. And then as this, I'm going to make up a point for that. I'm going to say that that's like 5 comma negative 2. Anytime I'm having trouble with a point, I'm just going to take that point and then go, okay, the x is 5, the y must be what then? 1 over that, which makes negative 1/2. So then my new point would be like here. So then, oh, it's here. Okay, good. Now I got an arrow going this way. I got an arrow going this way. There's only one little spot left right here, and it goes up like this. There we go. That's generally how to do a inverse reciprocal function. All right. Yes, I got an arrow on it. Do you mean in here? Where? Here? Okay. That would stop because the way I have mine graphed, there's a dot here. It's just a point. And the way I'm interpreting that point is that it would be at like negative 5 comma negative 1. And that means that I could just take it point by point and say, what would that have? Negative 5 comma, well, I put 1 over negative 1. So it's like, oh, that point is the same on both. Yes? Like here? Okay. Exactly. So when you say, let's pick a name for that. Let's say that this is negative 4 comma 0. Do you get that the x doesn't change? So it would be negative 4 comma, wait a minute, you can't do that because it's 1 over 0. So then how do you handle it if it's 1 over 0? You put an asymptote. That's why that red asymptote line right here, that's why that's there. Okay, so there's reciprocals. What else do you want to know? Okay, maybe you're just tired. I did get a bunch of questions in the other class that are totally different than your questions. So I'm going to record. This is obviously being recorded right now. I'm going to post this video. And you, when you go look, you can always look for the ones. I have a couple other classes that I've posted. I posted hour 1 and I posted hour 4. And so you could go look at their questions, which might be different. Yes? One last question. Well, I don't know. Maybe there's another one after that, but another one has been asked. 8, B as in banana. All right. Well, there's 2 concepts around that you need to know. Fraction problems are perennially hard for everybody. So I've tried to stress since the beginning of the year, if you have a fraction in your problem, get rid of it. Clear the fractions. So do you get that I could multiply this? Somebody's not with me. Thank you. You could multiply this by something that would make the fractions go away. What could you multiply by? Yes. Very good. Not just 7, because that would fix one of my problems. 7x. Because if I multiply by 7x, it fixes the 7 and the x. And now I have cancel, cancel, 7 plus Cancel, cancel. 3x equals 7x. So sometimes there's fraction problems and you don't even know you have fraction problems. Like in one of the problems, there's something like this. This is not exactly what you have, but let's say that there was this. 1 over n plus 3 to the negative 2 is equal to 17. The kid might know, well, obviously I have an n in the denominator, so I'm going to times everything by n. That's great. That's a good start. But where is there another fraction that they might not be noticing? Would you all, please, for a moment, write down what you think 3 to the negative 2 is? Write this down. Turn it my way. I will tell you if you've got it right. 3 to the negative 2. Just actually multiply it all out and get me a simple number. Good. Good. Not negative, though. Good. It's easy to make that mistake. Good. That's not it. Good. Good. Yup, yup, yup. Yup, yup. You're okay. Just the 3. Okay. I get what you're doing. You're putting it in the context of an equation. Can't see yours because it's too dim. What does it say? Just say it. That is correct. 1 over 9. So do you get that this really has two fractions, 1 over n and 1 over 9? Now, I know that's not exactly what you have in your packet, but you can kind of figure out that it's like that and hopefully learn how to clear the fraction there. Okay. Anything else you want to ask? Yes. Okay. I just covered that because it had to do with clearing fractions. You should know how to clear a fraction out of that. Yes. Skills around 4B. Okay, so I'm being asked about a question where they have an f of x, and then they ask them to find like f of x plus h. I know I'm not doing exactly what you want, but that's okay. I can get close anyway. So f of x plus h. Well, first of all, what's f of x? It's up here. And there, if I had asked for what's f of 5, that would have been like laughably easy. You just stick 5 into that equation, right? So all this means is stick in x plus h into this equation. Well, where would it go? Where do things always go? Into the variable. So this will be 6 times x plus h minus 5. Now what if that was squared? Well, then you'd have to square it. Okay, and you multiply it all the way out and you'll get an answer. And usually there's a complicated one that's like this plus this. Well, that's really not even that complicated because I know what f of x is. It says so right on my screen. F of x is 6x minus 5. So I can just replace this one with 6x minus 5. And I can do this one by sticking in x plus h into here. And I'd have 6 times x plus h minus 5. And then I could add that. Again, I know I'm not doing exactly what you want, but that's at least enough help on evaluating functions with variables. Any other topics? Seeing no hands, I think I'm going to give it a rest. So tomorrow, as things due, make sure it's done. Make sure it's ready. Because if it's late, you'll have a 10% penalty and you're not going to be able to see it for about a week and a half because it'll take a long time to grade it if we don't grade it together on Friday. Yes? No, this is just getting graded with a simple however many rights you get. Okay. The other part of the test is Marzano style, the part you do in class. Usually, even though this is not Marzano style, the average score on this thing is like a 90%. Okay, so there's usually a few people, though, who haven't been working on it and just all of a sudden, oh crap, I got to turn it in and get like a D. But that's usually the exception. I bet you the average in here will be like a 90%. So, all right. That's all I have for you for today. Remember, there's other videos you can watch.